How are you all today?
Good.
Excellent. I'm good too. I'm really happy to be here. Happy to be in London. Real quick introduction. My name is Edward Thomson. I'm a product manager at GitHub. I work on GitHub Actions. And I was hoping to tell you a little bit about what that is in case you hadn't heard of it, show you what you can do to enable your repositories to either do continuous integration, sort of build, test, and deploy, or to do some more exotic things that are outside the realm of a traditional CI/CD system and sort of run some automation within your repository. So if I look back, if I just kind of rewind a little bit, the really impressive thing about being at GitHub is that it is, in many ways, the home of software development, right? And I'm not trying to, be too grand about that, because a lot of people use different platforms for hosting their software, right? Not everybody uses GitHub, and that's totally understandable. But everybody uses something that at some point was developed on GitHub, right? Because the open source community, most open source projects are on GitHub. And most of us are now using open source within our projects, the software that we're building. So at some point we interact with GitHub, either directly, whether we host our software there, or indirectly, because we end up using some dependency that ends up there. And so one of the interesting things about working at GitHub is trying to understand how y'all use it and how we can make your lives easier. Again, whether you're using it directly or indirectly. And one of the problems that we have as Hubbers, as people who are working on GitHub itself, is that we have software engineers as our customers. And that can be challenging because y'all like to build stuff. And so when we put GitHub out there and give it to you, a lot of you look at it and say, cool, that's great, but I want to do this instead, or this is a great starting place for me. I want to take it and extend it. And I think that's great. I think that we need to let you do that. And so one of the things that we've been doing over the last couple of years is trying to find ways to serve you in that regard. So the first thing that we did was we created these things called GitHub Apps. The idea of a GitHub app is that it is a sort of well-defined little bit of code that you can take and extend, right? You're given webhooks. So every time anything happens on GitHub, we fire webhooks that you can subscribe to. Whether that's creating an issue or opening a pull request, that could be creating a new release or just tagging something. Every time you do anything on GitHub, we will fire these webhooks, and you can listen to them. And then you can do your own thing. You can talk back to it with our API, and that's a GitHub app. And I think that was a great start, right? The problem here is that you need to bring your own infrastructure, right? So GitHub will fire you an issue comment, but you have to have a server listening, whether that's something in your data center, something in the cloud, maybe if it's serverless, if you don't have super hardcore requirements. Maybe it's a server under a desk, right? We all know how well that works out. And so the problem is that you're hosting your own infrastructure. And that's fine for some things, but it's not really necessary for everything, right? Because when you're hosting your own infrastructure, that starts getting expensive. Whether that's an actual cost, like you're paying for a server, or a fixed cost, or a sort of more abstract cost rather, with that server under the desk that's going to get kicked over and turned off, and all of a sudden your infrastructure fails and you don't even know why, because you have this dependency. So we rewound a little bit and said, well, maybe we can fix the infrastructure problem. And that was sort of the genesis of GitHub Actions. The idea is that instead of making you bring your own infra to the party, we'll host it for you. We have servers in our data center. We have SREs that manage them, and an ops team that's on call. We can take care of that burden for you. And so the idea of GitHub Actions is we will still let you listen to the same events, to those same webhooks. So every time somebody creates an issue, every time somebody opens a pull request, whatever, we'll fire these events, but we'll fire them into one of our own pieces of infrastructure. So now you can define this and respond to it even, and you can create this and script it, but we'll take care of it. And that was the idea of GitHub Actions. The idea is that, you know, instead of making you bring your own app, we'll host it for you. And so we launched this a little over a year ago in beta. The idea was, I think, still a great idea. What we did was we gave you a Docker container and let you, run some things in containers on our Linux servers. And they weren't very powerful, but that's okay because, when you're responding to a new issue, it doesn't need to be powerful. And so we were really excited about the things that people would build, and we put it in beta, and we got a response that everybody hated it, right? The idea was really good, but the thing that people want to do, as soon as you give this to them, they're like, great, I can do something when somebody opens an issue. I can do something when somebody opens a pull request. And with that thing I want to do when somebody opens a pull request is run a CI build. And we were just not geared up for that. If you had a Node app that ran on Linux, didn't require a lot of CPU to build, probably fine. Worked okay. If you have an iOS app that needs a Mac to build, that's not gonna work. Like, not at all, right? So we really quickly realized that we had a good idea, but the execution wasn't quite there. So we sort of went back, retooled, and came out with an update. And in that update, we basically give you virtual machines to run on instead of requiring you to run inside a Docker container. So now you can run GitHub Actions in either a Linux virtual machine or a Windows virtual machine in case you're, building .NET Framework, or a Mac in case you're building an iOS app. You can still run things in Docker containers if you want. You can create Docker containers, you can compose Docker containers. We can still support all of that sort of Docker magic that we had, but now we can do it in different places as well. So we're no longer tying you to Linux. And this was what we released actually just a few months ago into GA. So this is now generally available. It is ready to go for all your workloads, whether that's responding to an issue, doing something when somebody creates a release or a tag, or actually doing continuous integration and deployment. So we're really excited about that. Let me actually, there we go. Let's see if this is gonna work. Let's actually take a look at what that looks like. There we go. So here I have a super simple Node application. It's got a backend that has a REST API that you can call for doing arithmetic, simple arithmetic. 1 + 1, 2 + 2. So if you ever need, simple arithmetic as a service, I've got you covered. It's also got a little front end right here. Kind of looks like the sort of pocket calculator that you might have had if you're super old like me. This is what we carried in our pockets before we had iPhones, right? If you're my age, you probably remember. So 4 + 4 = 8. Cool, does its job. What I want to do here is I want to open source this, and I want to be able to take contributions from the community. And when I do that, what I really want is to make sure that those contributions are good, right? I want to do a continuous integration build. I want to run my tests. I hope that this isn't like, earth-shattering. I hope that everybody's seen CI and is familiar with it. So I'm not going to, belabor this too much. But I do want to show what it looks like in the context of GitHub Actions. So if you have a GitHub repository, you might have noticed that now you have this Actions tab up top. That's sort of the gateway to getting started with GitHub Actions if you haven't already. It's also where we'll go and look at our workflow runs. So I'm going to click that tab. And this is how I set up a new CI/CD build. The first thing that we do is we scan your repository. We use a tool called Linguist to look at what is in your repository. If you've ever clicked on this button right here, this bar rather, that's the same thing that we use here. We actually analyze your repository to find out what kind of code you have in it. In this case, I have JavaScript. So when I go to the Actions tab and I have this sort of get started workflow, it uses that same analysis, and it knows that I have a JavaScript repository, so it offers me some JavaScript workflows that I can use. And this one right here, node.js, build and test a Node.js project. I'm going to choose that one. Just click Setup, and I've got YAML. So GitHub Actions is all defined by YAML. YAML is like the language of DevOps at this point, right? Whether you love it or you don't so much love it. It is, in fact, what everybody uses, and it's what GitHub Actions uses as well. So this is the YAML that defines my workflow. So this will run, in this case, every time somebody pushes into my, my repository. I'm going to go ahead and commit this workflow so that it'll actually queue a build while I sort of look at what that YAML actually looks like, right? So because I did do a push into my repository, if I hit reload, it should have queued should queue a build. There we go. So that's actually running right now. So while that runs, let me actually just unpack what is in this YAML. Right? I'm going to go ahead and click Edit. There we go. So my workflow has a name. Very straightforward. It's also got this clause right here, on. Right here, now it says on push. This is actually how you trigger things, right? So just like we used to fire webhooks that you can listen to, that's the same concept. So I'm listening for push events. I could listen for pull request events. I could listen for issue events. And I can even type it more narrowly, right? So let me say this. So for those of you who groaned, I did hear a groan when I said that we use YAML. This is what makes YAML bearable in my mind. We've actually got autocomplete. We've got syntax highlighting. See, you've got red squigglies right here because right now I have on with no value. It says the value cannot be null, and it is actually suggesting me the things that I can do. So I can run on push. I can run on pull request. I can run when a deployment starts. I can run on Golem. That's a weird one. If anybody's ever dug into the GitHub API, Golem is actually was the internalish name for our wiki. So all of our webhooks are still called Golem for the wiki. So I can run every time a wiki gets updated. So I've got a real wide range of things I can do. It's not just a CI/CD platform. But in this case, I'm going to keep it on push. Okay? And then what happens is I'll define some jobs. Jobs will run in parallel on different machines. I just want to have one job, and that's my build job. It's going to run on Ubuntu latest. Again, we have Linux machines, we have Windows machines for you that we host, and we have Macs. We actually have to go and rack Macs because you can't virtualize it. That's an Apple requirement. So we've got a lot of trash cans taking up a lot of space in racks because they're not really designed to go in that way. Really not space efficient. Pro tip, don't ever run a data center full of Macs. Then we've got actually my favorite part of GitHub Actions, and that's our matrix support. A matrix lets you really easily define a piece of workflow and then repeat it. So I can define steps that I want to run, and then I can define a matrix that defines that will let me expand those steps out into, in this case, 3 different runs. So what I want to do is I want to run my workflow on node 8, node 10, and node 12, just to make sure that it's compatible across all of them. So I can define a matrix. And this is just a key value mapping. This is like super simple variable substitution. There's like nothing advanced going on here. So what I'm doing is I'm setting a key called node version. And when my workflow runs, it will run my steps with that key set to 8.x. And then it'll run it again with that key set to 10.x. And it'll run it again with that key set to 12.x. And in my steps, I can actually use that variable substitution, and that looks like that. So what I'm going to do is I'm going to run this action called setup node, and it'll run with 8, 10, and 12. So basically that just puts sets up the environment for node and puts it in the path and those sorts of things. And then once that's set up at the particular version, I'm going to npm install to get my dependencies. I'm going to npm run build, and then I'm going to npm test. So with this, and this is just the sample workflow. Again, this is just out of the box. I just clicked go. You know, it detected that I had a Node.js application, and this is what it gives me. So when that runs, and that was running while I was explaining that to you, what I actually get is one run with 3 different workflows. That variable expansion in the matrix ran on 8, 10, and 12. And I can click in there and see what it actually did. So I can expand these steps out. npm install, put in my dependencies, npm run build, JavaScript. Nothing to do here. But that's obviously useful if you've got TypeScript instead, or some sort of compilation script in a build script. And then finally npm test. And in this case, it went through and it makes sure that it knows how to add 2 numbers. So again, not the most impressive app in the world, but even when you're doing simple math, it's good to have unit tests, because that stuff can break, right? How can it break, you ask? Well, JavaScript, you can break anything. That's my favorite part of JavaScript. So like I said, I wanted to open source this. I want to allow contributions. And so what can happen is, let's say somebody comes along, they take a look at this app, they open up arithmetic controller, this is the back end, they scroll down and they say, oh, okay, well this is obviously the mapping of how arithmetic works in this, but something looks weird, right? Add looks kind of weird. I don't know what's going on here. If I were not a JavaScript expert, and I am not a JavaScript expert, I would look at that and say, that looks weird. Subtract looks totally normal. A minus B, that's how you subtract numbers. Multiply is fine. A times B. Divide, yeah, it all checks out. It's just add is really plus A plus plus B. I bet we can simplify that, right? So I'm going to click edit. I can edit it right in the web. Come down here, just make it A plus B, right? That's how you add 2 numbers, surely. I'll scroll down here. Give it a nice title, open a pull request. There we go. And once I click create pull request, now what happens is we will actually queue a workflow build with GitHub Actions, right? And this isn't anything groundbreaking here, right? This would happen if you used Azure Pipelines. This would happen if you used Travis. But of course, it also runs when you use GitHub Actions. And I can click into one of my runs. Oh, in fact, geez, they've all failed. Oh, wow, what's going on here? Let's open that one up, expand that out. And we can scroll through our, Well, let's zoom in. So this is actually the way that unit tests are reported in this framework, like a diff sort of, a get diff sort of result. What we expected was that adding the numbers 21 and 21 would give us 42. What it actually did was give us 2, 1, 2, 1. Ooh, JavaScript. So what happened is, when I had plus A plus plus B, JavaScript was coercing my stringy things into numbers, right? Without that, A plus B is string concatenation. So 21 plus 21 gives us 2, 1, 2, 1. Ouch. So that's why you have unit tests, even when things seem really, really simple. So we know that this is not a good pull request. So as a maintainer, I would not accept it. I would, come up with a nice way to do that, hopefully. But this protects us from getting code into our master branch that isn't good. You can turn on branch protections at this point to really enforce it. I don't know about y'all, I used to have a coworker, he would write a bunch of code, check it in, get in his car and drive home without having actually built or tested it. And so this was many, many years ago before CI/CD was commonplace. And so this is, I think of him every time I accidentally, break something in a pull request and it doesn't even compile. So, which happens, there's no shame in that, but we need to keep it out of our master branch. That needs to stay healthy. So that is, the value prop of CI. And I hope you all are doing it already, but GitHub Actions makes it quite a bit easier if you're on the GitHub platform to get started. So like I said, when we introduced GitHub Actions, the goal was repository automation. At first, we didn't have CI/CD in mind. We could have built this back then, even on those Docker containers. Things that are harder to build are .NET applications, because you might want to run that on Windows. I like to run my CI the same place I'm going to deploy it. If you run your CI on Linux, deploy to Windows, or vice versa, you never know what kind of weird problems you might have. Case sensitivity is different. The legal file names that you can actually have are different. So I think it's important to run CI the same place you do your deployment. So I've got a .NET app, and if I were deploying it to a Windows platform, I could do that. So this is a .NET Core app. It's actually a Blazor app. I think that's what they call it today, not Razor Pages. It's now Blazor again. If you don't know what Blazor is, you should actually be in the room next door, because that's being explained. So I'm going to trust that you all know what Blazor is. I won't go too much into depth. But this is just a .NET Hello World app. It's super duper over-engineered because I have a shameful secret, and that is that I used to be a Java developer. So it is extremely abstracted. It's got various factories to build things. And I think that's fine, right? Because, like I said, Java. But what I want to do is I want to build it. So if I go to the Actions tab, the Actions tab, there we go. Just like before, when it scanned my JavaScript project, this is going to decide that I have a .NET application, which I do, and suggest a .NET workflow for me. So I'm going to go ahead and click Setup, and it's very straightforward. You can look at it. In this case, I want to make two changes. The first thing I want to do, I don't want to run on Ubuntu anymore, because if I want to deploy to Windows, I want to do my build on Windows. So I'm going to change that to Windows latest. That'll give me our newest version of Windows that we have in our data centers. And the other thing I want to do is run on .NET version 3.0.100. That is, I think that's the GA for .NET Core 3. I forget exactly, but that's like the minimum version for Blazor, I think. I seem to have that in my head. Let's give it a try. It might not work. I'm going to go ahead and commit this. And when I do, it's going to, again, just like before, kick off a GitHub Actions workflow run. So I'll click into there, click reload, click reload again. There we go. And it's actually started my run, so I can click in there. And my favorite thing of Actions is matrices. My second favorite thing is actually being able to watch the run live. So you can see it's doing our git clone. It's setting up .NET Core, in this case, again, version 3.0.100. It's actually installing it right now, so it turns out I got that version number right. That's great. And then it's going to do my .NET Core build. If I had unit tests, it would actually run them. Whoops. That one's on me. So the cool thing about this is that it is actually running on a Windows server. So again, I think that your deployment target and your CI platform should match. I think that's a really powerful reason that we brought in Windows machines. There we go. It's actually doing my .NET build. 3.1.101. I was close. I was off by one, but it figured it out. See, I still remember how to write software. Even though I'm a product manager, I can still write software. I have off by one errors still. So again, we have Linux, we have Windows, we also have Apples. Like I said, we've racked a bunch of Apple machines into our data center so that you can do your iOS builds and then, I don't know, deploy to the App Store, or if you're, whatever the reason you might want to deploy to using a Mac is. So here I've got a game that I've written in Swift. It's a concentration game, or I don't know what you call that in the UK. Is it still concentration? The idea is that you have tiles that you need to match. And sorry, I don't expect you to read this, but I do have, again, tests for that, so you can see exactly how it goes. There we go. So like I said, I'm a product manager, not a software engineer anymore, and so I needed to figure out how to test if you could win the game, so I brute forced it. I'm sure there's better ways to do this, but this is the product manager's approach to problem solving. So one of the things that I want to make sure that I'm able to do is actually, just like before, run a build and run unit tests so that if somebody's contributing or if I'm working, late at night, that I can't contribute or I can't push something into master that breaks the build. So the cool thing about having physical Macs in our data center is that you can actually run all of this. It's got the iPhone, the iOS simulators installed. So you can actually run all of the UI tests within GitHub Actions. So if I pop back to, there we go. So if I pop back here and go to the Actions tab, it will offer me up a Swift workflow, which is indeed exactly what I'm running. This time it's, instead of running on Ubuntu latest or Windows latest, I'm gonna run on macOS latest. I'm gonna change my workflow just a little bit. I've got this crazy Xcode command that will actually run the iOS simulator. And so I want to change this. So I'm going to change run. There we go. Oh, that's very, very long. So the run command in GitHub Actions is basically just something that will run in a shell. In this case, bash. I'm going to go ahead and start my commit. There we go. And again, when I do, since my trigger is on push and by committing this file, so the moral equivalent of push is something got merged into my repository, somebody ran git push on the command line, or somebody used the web and edited directly in master. Don't do the last one, please. That's not a super good practice, but I'm gonna do it here for the sake of demonstration. So that means this workflow is now running. If I go into it, I can open this up. I can expand this tab. Nope, hasn't quite started yet. There we go. And we can see that it's actually going to do my compilation. And then it's actually going to start running my unit tests, even my UI tests. So I can scroll down, and it's starting my UI tests right now. So it's simulating an iPhone 11, running iOS 13.2, in fact 13.2.2. There we go. And it's actually doing the tests. And so in a second, it will actually start debugging output, and my unit tests here will tap through, well, virtually, tap through every tile in that game to make sure that it is, in fact, winnable. And so you'll actually see that output at some point, saying that it's actually doing the taps. There we go. So it's starting up, tapping each button in time. So that's really cool. You can use GitHub Actions to actually make sure that your UI works. And this is true. It doesn't have to be an iOS app with Swift. You could do this with Selenium or any sort of browser-based tests that you have. You can run those right in our harness as well. So that is CI in a nutshell. So we're doing our build, we're doing our test. Now often we would want to do a deployment. So I want to come back to my calculator application. And what I want to do is deploy it to a cloud provider. So if I click on the Actions tab, I've got my workflow runs, including my broken pull request. But I want to create a new workflow. Instead of a CI workflow, I want to do a deploy workflow. And so we've actually partnered with some of the clouds to bring starter workflows right into our getting started experience. So you can deploy to Amazon, you can deploy to Azure, you can deploy to Google really easily. In this case, I'm actually an Azure user. I used to work at Microsoft, so I'm very familiar with Azure. That's what I want to use. So I'm going to go ahead and click to set up this workflow. And what this will do is it will go ahead and get started and create a build a node application and deploy it to Azure Web App. And so most of the things that we've done so far, we've just been running commands on the command line. This one is a little bit different. This last step, the deploy step, instead of a run, it's a uses. And it says uses Azure Web Apps deploy at v1. So this is using an action. So we can have workflows that are just running shell scripts, running command line steps. Or we can have workflows that use actions. So an action is just a reusable piece of code that you build and you put in a Git repository on GitHub to share with others. And in this case, the Azure team has built this web apps deploy action. And what it does is, well, like the name suggests, it deploys a web app to Azure. It needs a little bit of configuration right here. And so it's, you just give it an Azure publish profile in your secrets, and you're basically good to go. What is a secret? If we go into our repository settings, we can go to secrets, and we can add basically variables that will get expanded by the workflow, and we'll hide them from, we won't put these in the logs, we won't display them within the UI. They are, in fact, intended to stay secret. And I've set one up, that's my Azure publish profile. I did this ahead of time so that I didn't have to copy and paste it in, because I'm sure y'all are very trustworthy, but the folks watching at home might take my publish profile and start crypto mining. I don't have that kind of money, so I'm just gonna hide it. So I've already configured that as a secret. And then I'm gonna go again to my Actions tab, go back to the new workflow, select the Azure again. And I've actually made a few changes. Let's find my, sorry, there we go, hiding back here. I want to actually use a slightly different version. There we go, because I've already gone ahead and set up an app. It's called CalcJS. I didn't actually set up the secret that the starter workflow did. Basically, it just puts it in as a secret. I don't need that secret. Nobody needs to I don't need hidden the fact that my app is named CalcJS. And then again, I'm going to use that publish profile. And so the other thing that I've changed is that I've changed the trigger. So this is not in the default. The default runs on push. What I want to do is run on release. And so I'm going to go ahead and check this in, and then I'll show you what that looks like. Right. So I just checked this in. So my default, my CI workflow is now running. This is the one that runs on push. It runs my build and it runs my test. What's not running is my deploy workflow, because I changed the trigger. I only want to deploy once I feel good about my project, once I've done some manual testing. And the way I want to do that is by going through the new release process on GitHub. So I'm going to click Create New Release. There we go. We'll call it V1, and we'll click Publish. So if I go back and look at my workflow YAML, the Azure deploy workflow, again, I've changed this trigger. So we were looking at on push before, now I'm running on release. And release is a broad category of actions on GitHub. I only want to run when a release is created. So if I just left this blank, I would run on all release types. So if somebody deletes a release, I would run my deployment workflow. That's no good, right? You're probably deleting a release because it was bad. You don't want to publish it. I only want to release to production when I've actually created a new release. And so I just did that. So if I go over to my Actions tab, I should see that running. Indeed I do. There's my deploy to Azure workflow. And in fact, it claims to have succeeded. What I didn't do was change any code, so I can't prove that. Let's actually make a little change, and then we will do another deploy. So if I go into my public file, folder rather, this is where my static components go. I've got a new background I want to use. And I don't know if y'all know this, you can just drag and drop right into GitHub. So I can drag and drop a new file in. I can commit it. This is great for things like wikis. This is maybe not so great for your actual source code, you know. And whoops, let me again go back into public, and I'm going to change my CSS. I'm going to change the background color to match the new image. Whoops. Let me click the pin. I can edit it right in the browser. 681b1b. There we go. And I'll go ahead and check that in, and then I'll tag a new release, and it will do a whole new deploy. There we go. Call it V2. Go ahead and kick that off. Great. So that actually did do a new deploy. It also kicked off the CI as well, because I did a push. While that's running, and it will take a minute to run, and do the deploy, restart the web app, et cetera. It takes just a minute. Let me actually show a different deployment type while that's going on. One of the other things that we've done at GitHub is we have, there we go. Great. We have another new product within GitHub. We also released it to general availability in November at GitHub Universe. And that's called GitHub Packages. And basically, GitHub can act as a private package registry, or a public package registry, whichever you prefer. The idea being that, like, maybe if you're producing NuGet packages, like I maintain an open source library for .NET. And so I build NuGet packages and I publish them to NuGet.org so that y'all can download them, so that you can just type NuGet install or .NET install, whatever, my package, right? And that'll pull it down from NuGet.org. But I only want to put releases there. I don't want to put, pre-release hacky things that I want to test. So what I can do is I can push my final releases to NuGet.org. I can push my interim NuGet packages, my testing NuGet packages, up to GitHub Packages. And that way, people who want to test my, the very latest cutting edge version of my open source library, they can point their NuGet registry to GitHub Packages and get the very latest, newest version. We can collaborate on that. We can work on it, test it. I can get feedback. And then once it's actually released, I'll publish that up to NuGet.org. And so GitHub Packages will host NPM. It'll host Ruby, Maven, Gradle, Docker, NuGet, et cetera. And so this is a really cool way to work with that sort of workflow. The thing that I like most about it, though, is that it actually integrates really well with GitHub Actions. There we go. And so I can do a deploy to Azure just like that. And if I hit reload, this now should be red. Well, the background's red. I meant to update the image too, but alas. That was my bad. Instead of just deploying to Azure, though, now I can also create a deployment out of this project to GitHub Packages. So if we look here, one of the things I have in here is a Docker file. So when I am deploying this, I could do a normal web app deploy like we did, or I could build a Docker container and deploy that container to a container registry, and then ultimately to a web app in the cloud or in my data center, et cetera. So this is really straightforward. All we do is run npm and then bundle it up into a Docker container. But one of the things that I like to do is if I'm going to do a Docker deploy, if I'm going to do a container deploy to the cloud, if that's the way I release my application, I want to be able to test that Docker container exactly as it's going to be deployed locally. And so one of the things that I can now do is run a GitHub action workflow that will create a Docker file and then publish that to GitHub Packages. Then I can download it, test it, make sure it works before I actually deploy it to production. And so if I go back to my Actions tab, I want to create yet another workflow. So we'll click New Workflow there. And again, it detects that I'm a JavaScript repository, but I can also scroll down and look at all these other starter workflows. One of them is create a Docker image. Great. And the default is super simple. It just runs Docker build and gives it a tag. It tags it with the current date. So that's a reasonable version number. This is, if you're not familiar with this syntax, this will just give you, instead of the date in text, it will give you the number of seconds since the Unix epoch, January 1, 1970. So it's just a monotonically increasing number. Makes a great version number. So this works really quite well. But what I want to actually do is take it a step farther and publish this to GitHub Packages. So I'm going to go ahead and just snag this workflow here. And I'm going to paste it in. This also runs on release. So I'm going to create a new release so I can kick it off, because it'll take a second, and then I'll explain what we're actually doing. So go back to the Releases tab. If I create v3, now we've got two workflows that run on release creation. We've got the one that deploys to Azure, and we've got this new one that will deploy to we'll create a Docker container and put it in GitHub Packages. So let's go back and look at what it's actually doing. There we go. So again, we're running on release. We're going to do it on Ubuntu. We're going to use node 12. And then we are going to, the first thing we do is we run Docker login. So we actually need to log into our package registry, in this case GitHub Packages, and we'll log in with this password that is the GitHub Token secret. Now, if we remember, when we looked at secrets before, what we didn't, we saw the Azure publish profile, but we didn't see this GitHub token. So this is actually something that GitHub puts in your workflow run automatically. It is a token that you can use to access your repository. And if you are running, on a release or running a CI build, it actually has write access to your repository. If you're running a pull request from a fork, it does not, right? So we want to keep that secure so that nobody can just come in and start running, running things that can write to your repository. So forks don't get a writable version of this token, but you do, and so you can use it to do things like publish to GitHub Packages. So it's basically already set up for you. All you need to do is log in, and then we'll build our Docker container, and then we'll push it. So Docker push to docker.package.github.com, that is GitHub Packages, and we'll give it the name of our repository, and we'll call it app, and we will give it a version. And again, that's the same version that we used before, which is the number of seconds since January 1, 1970. So if I go over to the Actions tab, I should see that this has run. Oop, actually it failed. What did I do wrong? The magic of live demos. Turns out I need a different name. I've already got a package named app, so let's go ahead and give it another name and start a new workflow run. So instead of app, we'll call it app2. Start that commit, and go ahead and create a new release, and let it run one more time. Okay, and we'll come back. We'll give it a minute. We'll let it run, and we'll come back to that. One of the other things, while that's running, one of the other things that I love about GitHub Actions and its integration with other GitHub products is our integration with the new security tools that GitHub has been producing. We have a tool called Dependabot. That came in through an acquisition. This was a really cool tool that we really loved, and so we wanted it to be part of GitHub. And so now it is. The idea of Dependabot is that it will look at your dependencies, the open source projects that you rely on within your own software projects. And Dependabot can analyze what you're using. So most of us are using open source projects. Sometimes those open source projects have security vulnerabilities. And these are widely published, they're announced so that you know that you can upgrade them, except most of us aren't like reading the mailing lists for the software projects that we use. And even if we were, you could have some transitive dependency, right? Like you could depend on a project that depends on a project that depends on a project that has a security vulnerability. And you don't even know it, obviously, right? So the idea behind Dependabot is that it does know it. All it has to do is look at your project, see what you're using, and look at this database of security vulnerabilities, because there is a common database because they all go get what are called CVEs. CVE is, I think it stands for Common Vulnerability and Exposure. It's a security bug. So you can easily match the tools that you're using to this database to know whether you are vulnerable. And attackers do this too. If you're an American, like I am, you have to deal with credit bureaus and credit reporting agencies. And they basically have all of your information about your social security number and the loans that you have, how much money you have. This is bad stuff to get out. And they also happen to have websites. And websites sometimes have vulnerabilities. And in fact, one of them did. I'm not going to name names, but one of them had a website with a security vulnerability. And an attacker just like blasted the internet looking at the headers that are returned from websites and saw that one of them was vulnerable to this app. Like the header said, hey, here's the software that I'm using. And it was vulnerable. So they just found a tool that would get them into this website, got in, and from there they had a foothold into the network, eventually got into a production database of credit card or credit information, and that's why, like, to this day, I still get random people trying to steal my identity. It's great fun. Had they used a tool like Dependabot, there are a lot of great tools that do this, but Dependabot is built into GitHub, so it can actually just tell you exactly when this happens. So I would like to say that I planned this, but in fact, this happened organically. I built this repository a while ago, and one day this message popped up telling me that I had a security vulnerability. So GitHub actually scanned my repository, and this is an opt-in sort of thing, right? This isn't something that you have to do. And it told me this. It also only shows the owner this, right? Only the owner can see this message. So it's not like anybody browsing your repository on GitHub, this will be super obvious to them. So The cool thing about Dependabot is that not only does it know that I have a security vulnerability, it also knows how to fix it. So if I click View Security Alert, it will take me there. The problem is Lodash. If you've been hacking a lot of JavaScript, you might have seen this warning before. But if I click in, I can scroll through, and it'll tell me exactly what to do, right? What I need to do is to upgrade Lodash to version 4.17.12 or later, and it'll tell me exactly how to do that. This is the line that I need to change. Great. So I can go and make that change. The cool thing, again, about Dependabot is that since it knows that, it can actually do this for me. So if I pop over to pull requests, it actually has. So Dependabot has now opened a pull request for me. So this is an automated pull request that fixes that security vulnerability. Dependabot has done that. If I look at the files changed, it did exactly what it told me to do. There we go. It removed version 4.17.11. That's the vulnerable version. It's added version, there we go, 4.17.15. That's the newest version. Okay, well that's helpful, but since we have GitHub Actions running on this project, we also know that this version update was good. You know, assuming we have good unit tests, and I feel good about my unit tests, we now know that that version update that Dependabot did for us worked reliably. So I have a very high confidence that I can just click Merge Pull Request and fix this security vulnerability. So between the time that the vulnerability happened, I've gotten an alert in my email. Every time I go to the repository, I see this alert. And I've got a pull request that fixes it, and I know that it fixes it the right way because I have my builds and my tests passing. So I am really, really excited about that in particular. I think that's my, what did I say? That's my third favorite part of GitHub Actions is how it integrates with the other tools and other products that are on GitHub. And like I said, it does integrate with GitHub Packages. Let's make sure that, let's see why that one failed. Oh, I changed it in one place and not the other. So if we go back and look at my container workflow, I changed the name of the Docker container that I was producing. I originally called it app. I had to change it to app2 because I already had a container, a package called app, because I ran this earlier getting set up, but I forgot to change it in the second line that does the push. That's my bad. I need to create a variable. I'm gonna go ahead and kick off another build just so that it actually works before I finish up. So one more release. We'll call it V5, kick that off. And while that's running, I wanna say one thing about actions themselves, right? So we've talked about workflows. We've created a lot of workflows. And one of those workflows used an action. It was the deploy to Azure action. And I kind of mentioned that it was sort of this reusable component that you can publish and that multiple workflows, whether they're yours or you can put them, make them publicly available, can then use that action. And so I want to look a little bit more at what that looks like. So an action is a JavaScript application, or TypeScript if you prefer, that will run in the context of a GitHub Actions workflow. So we saw one, which was the deploy to Azure, but that is by no means the only one. If we go to the, let's open that. If we go to the GitHub Marketplace, you can actually see a number of actions that people have created and made available. So here's one. This one will help you build and publish a Jekyll site to GitHub Pages. Scroll down a little bit. There we go. This one will run Rubocop. So if you're a Ruby developer, Rubocop is the linter for Ruby. It's a style checker. It's really handy. We use it at GitHub all the time. And in fact, one of my coworkers has created this action to help with that. So all you need to do is say uses, what's it called? Rubocop action? Rubocop checks. All you have to do is say uses Rubocop checks. And it will in fact then run Rubocop. And the cool thing here is that it will actually put these check failures right in line. So it'll tell you exactly what the problem was. This is a poorly named method. It's using camel case. This person has opted into snake case as their requirements for their project. And so it will actually just highlight the line. And so this will actually drop in an annotation right within github.com so you can see exactly what the problem is. So this is actually a really, really cool, really well done action. So you can opt into using that. You can also write your own. So we've got this toolkit that will help you create your own action. So all you have to do is clone this repository to get started, and then you just go and write some code really easily, and that will let you, I don't know, deploy to your own infrastructure. It will help you run your own linting tools. Whatever you want to do and share with the community or within your organization, you can do by building an action. Let me give you a more concrete example of that. So one of my other coworkers has built an action that will run every time an issue is commented on in a repository. How many people have played Untitled Goose game? A couple of y'all? Okay, for the ones that haven't, A, go do it. Go get it. If you don't own a Switch, go buy one and then buy Untitled Goose game. It really is great. It sounds ridiculous, I know. So you play a goose. You are a goose. And you are in a town. It's a town, it's a lovely town, and it's full of lovely people. They're just trying to go about their day, and you are a goose. And you sneak up behind them and, like honk to surprise them. And oh, it sounds ridiculous, but it is quite fun. And so one of my coworkers has created an action that brings that to GitHub. So what I'm gonna do is add a comment to an issue. And if we go and look at my workflow, I have a workflow that runs every time an issue comment is created. So anytime somebody comments on any issue, this workflow will run. And it will use his action. It's called honk action. And what happens when his workflow, when his action runs, if I open up this issue that I created and then commented on, my comment is now gone and it's replaced by an angry goose. So what his action actually does is anytime you say anything except, or that doesn't have honk in it, your issue is removed and replaced with an angry goose. So it terrorizes your GitHub repository. Now obviously there is absolutely no use for this. However, it does sort of show the things that you can do with GitHub Actions. So you're able to respond to any activity on GitHub and then use our REST API to basically perform any activity in response. So although I've shown you a lot of continuous integration workflows, deployment workflows, and integrations with other GitHub services, I hope that this gives you an idea that it really is just an open-ended platform that you can use and you can extend GitHub with. So I'm afraid I am out of time. However, I'm happy to hang around and take your questions. If you are shy or if you are in a hurry, totally understandable. If you have questions, I'm still happy to answer them. The best way to reach me is Twitter. I'm at eThomson, that's Thomson without a P, so ETHOMSON. And I am happy to talk to you about GitHub Actions or I guess GitHub or Git in general. So thanks so much. I hope you enjoy the rest of the conference.